totality.
That's correct. That's correct.
Okay.
And here it is sweeping across Woolly Eye and on across the Pacific.
That's where we are. So if you notice on this path, a lot of the path of totality is on water. And we need actually firm ground in order for our telescopes to send back the best images. So that sort of talks about why we're here in Woolly Eye.
That's right. And in fact, these bands on either side represent the degree of partial solar eclipse you can see. So you can see that from the Philippines down to Australia, people are seeing partial solar eclipses.
Right. And here today we're not quite seeing anything yet, but very soon. But I'd like to talk about the journey to get here. Woolly Eye is an awfully remote place. So our crew actually spent 22 hours. It was a 3-airplane journey to get here until we arrived in Yap. Colonia is the capital of Yap, where we boarded a live-aboard boat called the Solitude 1. We spent about 2 days crossing the open ocean, and it was pretty bumpy. We got a little bit green until we got here to the Woolly Eye Atoll. Our first thing that we needed to do was to come ashore and sort of scout around. Where was the best place for us to put our telescopes, our satellite dish, where we get the best images? And we picked the runway. It's an old World War II runway. And then the next step, of course, was bringing all of that gear onto shore. We actually have about 56 cases of gear, about 2 tons. We need to bring it here to the runway, unpack it all, get it set up. We had cameras to set up. We had a lot of cords to plug in. The satellite people had to tune the satellite and make sure that they could hit the bird up in the sky. We had telescopes to get into place. Bill spent a lot of time aligning those telescopes, night after night after night. But we finally had it all worked out. We had everything sort of in place, which then for the next few days gave us an opportunity to sort of rehearse this, to think about what we wanted to do. But it also gave us an opportunity to spend a little bit more time checking out the Woolly Eye Atoll. It's an incredibly, incredibly beautiful spot. A beautiful blue lagoon, palm trees and breadfruit trees. The people here live quite a traditional lifestyle. They live in traditional longhouses. And here I'd say these are some of the chiefs. There's 2 chiefs here on the Woolly Eye Atoll. We met with them. We formally asked permission to be here. They were so kind and so welcoming. They offered to host us and give us whatever support we needed. The local folks, too, were so gracious. They offered us coconuts to keep us hydrated. They offered us food. I spent a little time in the women's longhouse as they were preparing food, again, mostly taro and breadfruit. We wrapped them up in leaves, banana leaves. I asked the ladies why they were making so much food. There were just piles and piles, big baskets of food. And they said it was because, as their tradition says, they needed to feed everyone who's coming here. And we have quite a few eclipse chasers on the island with us. People from all over the world have come here to witness the eclipse, as well as a lot of people from the outer islands. What you're seeing now is some of the weaving. You'll notice when you get here, everything's woven. Side panels of the longhouses, baskets. It's a beautiful place.
It really is. And we taught the students here how to observe the eclipse safely, what to look for during totality. They were amazing. They were really interested. We gave them all safe viewing glasses, and here's a kid just really smiling and enjoying looking at the sun yesterday.
I know, we've been so enthusiastically received by the local people here, and it's been such a privilege to be able to share what we know. One of the local women actually said that during a previous eclipse, they didn't know it was going to happen. So they actually gathered their friends and families and they went indoors to hide from the eclipse because they didn't know what was happening. So it's so great this time that we've been able to share with them what's going on, and they're all out here on the runway with us today to experience this.
Yeah, in fact, hopefully we have a little hole here in the clouds and we can go to the white light camera when it comes out. Okay. And, well,
so I guess we do have clouds. It's sort of peeping in and out. So it's a little dark right now. We were getting some good peeps there for a minute, but they've kind of disappeared now. So Paul, I have to say the last few days we've been spending a lot of time with Bill and the telescopes, checking out the sun, seeing what's going on, and it leads me to ask you, what is the sun again?
So the sun is a star, and at the core, the pressure and temperature bring together hydrogens, convert them into heliums with a loss of mass, which turns into energy, which comes out from the center, the core, out to the outer layers of the sun where the light leaps free into space from a layer called the photosphere. That's the part of the sun that we see.
Right. Okay, so we want to talk a little bit about the layers of sun that we're going to see today. So the first layer, the one that we kind of see with our naked eye if we were to glance at the sun, which you should never do, is the photosphere. So let's take a look at that. I think we're getting a little clarity here. So this is this a white light image that we're seeing?
This looks like a hydrogen alpha.
Oh, there we go.
There we go. So
there we are. We see a few sunspots. Is that true on the sun?
those may be filaments, but they may be sunspots.
Okay, fair enough. So what we're seeing...
They're filaments. They're filaments. This is a hydrogen alpha filter we're seeing, and there's a prominence on the top there.
Okay, so the hydrogen alpha filter is showing us a certain layer of the sun.
Right, above the photosphere, there's a layer called the chromosphere. And you'll see that during totality as a little thin pink to red layer around the edge of the moon on the sun part of the time.
Right, and one of the things I love about the photosphere is it's so active. There's a lot of activity happening there, including we sometimes see little prominences on the edge of the sun. I'm not sure if we're seeing any today.
Oh, yeah,
Let's take a look.
Let's take a look. So here we have the photosphere view. It's oh no, that's still the hydrogen alpha.
Okay, we're taking a look at the hydrogen alpha thing.
With the clouds coming in and out, we have to adjust the gain on the telescopes all the time. So it's a dynamic process. Oh, but there is a wonderful prominence that really shows up in that hydrogen alpha filter.
Holy smoke, there is a giant prominence right at the top of your image of the sun. It's going out a little in and out because of the clouds, but that's absolutely gorgeous, Paul. So what's going on there?
Well, the sun is a really rich in magnetic fields. Not only an overall magnetic field, but there are magnetic fields that twist up and penetrate through the surface, making sunspots and guiding in a dance the charged particles that make up the sun. So the charged particles move along the magnetic field lines, and as they move, they change the magnetic field lines. This is an amazing dance, and the result is charged particles from the sun reaching out into space, going out from the photosphere, through the chromosphere, out into the corona, the next layer of the sun. And that prominence is quite a bit larger than the Earth.
Yeah, that's incredible. In fact, I'm not sure I've ever seen a prominence that large before. It is really, really incredibly beautiful. So I think that we actually have an animation that shows, I hate to break away from this, but it shows some of the active activity from one of the satellites. We can see a lot of detail. So let's run that really quick.
So we have a satellite view of the sun. The sun takes about an Earth month to rotate once, so this is quite a bit sped up. And it just reminds us that sunspots are magnetic storms on the sun. Whenever you see a sunspot, think magnetic fields coming out of that sunspot, going back down into the sun.
And it is pretty incredible, again, to see the sun like this. We haven't seen this yet. It's very active, as you were saying. It's moving around these magnetic fields in a giant ball. That's absolutely gorgeous.
Eye when the photosphere is blocked by a total solar eclipse.
Right.
So it's it's the great treat of totality, is to see that corona as a white series of lines guided by magnetism out into space.
Yep, and the corona today, we actually have no idea what it's going to look like, right? It's going to be a surprise to us.
Well, you know, scientists have predicted that there'll be like 4 lobes of the corona, so we're going to check our actual view of the corona with the prediction.
Right, but like the other parts of the sun, it's magnetic and it reacts to this magnetism, so it's moving and changing. So it might not be a correct prediction.
We'll find out. You know, scientists, you stake your reputation on your predictions and then you test them.
Okay, so while we're waiting, let's take a look at the sun. We're again seeing this, I believe that's the H alpha view, and that beautiful prominence. You can see how large it is. Paul, could you take a stab at exactly how big that is?
I'd say that's at least 5 Earth diameters on the bright part, and the dimmer parts reach out beyond 10 Earth diameters.
Great. So actually, while this image is great, we have another image that was taken from a satellite, so we can see a prominence a little bit closer up.
Yeah, the clouds are about to obliterate our actual view, so let's take a look at a prominence from the past, and you can see that reaching way out from the sun.
That's right. So that's in the upper, sort of upper right of this image.
Right.
You see a giant prominence.
And those prominences are alive. They're in action with the magnetic fields of the sun guiding those charged particles out and sometimes back in to the sun. And there's the Earth to scale.
Right, so here you can see exactly how large those prominences. They're gigantic and very beautiful.
They are. I just love that one. It's so much in motion. So, in fact, those prominences can sometimes break free of the sun, as we're going to show you here, as coronal mass ejections, which are also sketched in the 1800s during a total solar eclipse. And so if you look at this, NASA satellite images of the sun, you can see giant clouds of ionized gas blasting out from the sun into space. As they continue out, those blasts can actually hit the Earth.
Oh, I see what you're saying. So these gigantic explosions on the sun are blasting particles at us, and those impact the Earth. And that makes me think that that's the hidden connection between the sun and the Earth I was talking about before, which means it's time for us to bring out Troy Klein from NASA. He's an education technology specialist. Great to have you here, Troy.
Thank you so much. It's a pleasure to be here.
Okay, let's check into the telescopes. I think we have a minute here, a little break in the clouds, so let's take a look at it.
Wow.
Could you fix it and get us the actual feed? Well, Troy, what do you do at NASA?
I have a couple different jobs there. I'm an education technology specialist, and I'm also the education and public outreach lead for a mission that's called the Magnetospheric Multi-Scale, or MMS mission. I'm the mission education lead for them.
And how does that help us understand the sun?
Well, you know, NASA has quite a fleet of satellites right now that are up looking at the sun and the Earth, and something that we call solar storms and space weather, because it's very important to us to know how to live with this star, our sun. And as you've been talking about just earlier, our sun is a magnet. It's basically a giant magnetic force, and it has an equator that's moving quicker than the north and south poles can keep up. And because of that, those magnetic field lines get twisted and tangled, and sometimes will create sunspots where there's a high concentration of magnetic force. Now, what we're going to see in just a moment is how that magnetic sun also interacts with our magnetic Earth. I have a great video if you'd like to see it.
Let's show that. Looks like aurora to me.
Oh, it sure does. Have you seen an aurora, Paul?
I have seen many.
It's the visual evidence that something is going on that started on the sun. And we're seeing some magnetic field lines right now that are coming out of two areas that look like sunspots. And when those magnetic field lines build up so much force, you'll notice that they start to stretch away from the sun, and something very important begins to happen that is actually the trigger of our space weather events. Now, as those field lines start to stretch and touch, boom, they connect and disconnect, and it expels a tremendous amount of energy and plasma and ions away from the sun in various directions. Now, the only time we're really worried about that, of course, is if it's headed towards Earth or where we have humans in space, and that can be very critical. Now, we're looking at this plasma. It takes usually about 3 or 4 days for the main effects of this to hit us, but the Earth is just amazing, and it's designed beautifully. It has an invisible magnetic force field that surrounds the entire planet. Now, you'll notice as these magnetic field lines of the sun come in, you'll be able to see them connect and disconnect with the Earth's magnetic field. And it doesn't stop there. Those field lines, the sun's field lines, actually pull the Earth's field lines behind the Earth as the Earth continues to regenerate field lines in front. And in the back, in the magnetotail, there was another reconnection event that just happened, which forced energy out of the tail of the sun or the Earth and also into the North and South Pole. And Paul, what happens when you put a lot of energy into the North and South Pole?
The atmosphere glows as an aurora.
It glows as an aurora, which is really, really amazing.
This is quite beautiful, and I think they're going to run some image from the ground, how this actually looks. There we go.
There we go. I had the opportunity with our team to go to Barrow, Alaska, and watch first light when the sun first appeared just for a moment over the horizon. And each night we would run out and see these beautiful green aurora.
Okay, hey, the sun just peeked out of a hole in the clouds.
Awesome.
Let's go ahead and take a look at that partial eclipse. Boy, it is really getting to be a narrow arc of the sun right now.
It sure is.
And we can see those filaments on the surface of the sun and hydrogen alpha, and the sun coming up.
With my solar glasses, I was able to see, it looks just like a little sliver right now to the human eye.
Excellent. Most excellent.
Oh,
Yeah.
exciting. I can also notice the lighting is starting to go down dramatically here around us.
That's right. Definitely. The sun is mostly blocked. It's getting cool.
It is.
It's much cooler here.
That's really amazing. I have chills.
Yay. Well, I understand that the MMS mission has a real goal to help us live on Earth.
It really does. We're really concerned about societal impacts and how we live here on Earth, and how the magnetic energy that we have and all of these solar storms impact us in space and on the ground, with potential blackouts and even damage to satellites. So NASA is very invested with people and partners around the world to be able to launch satellites into space that study solar weather and space weather. I have a video with me of an amazing mission called the Magnetospheric Multiscale mission that actually, it's almost the anniversary of their launch, and they launched on March 12th last year. Here in this animation that we're looking at, Paul, we can start that. You'll be able to see something called an Atlas V rocket. Now, what was really cool about being at this launch is we invited students from Texas and from West Virginia and all over the United States to be part of this launch. These students in West Virginia actually built a life-size model of their own that we have on display. In this animation now, you'll notice Florida way in the distance on Earth, and in just a moment, the nose cone has all 4 satellites. They're 11 feet wide, 4 feet high, 26 instruments aboard each satellite with booms that go out and antennas. And some of these antennas actually stretch out to 160 feet apiece. And you'll notice there's a minor charge between the satellites as they reach orbit or towards orbit, and then they're able to separate and start forming something that is like a tetrahedral formation. And I actually brought something, Paul, that I'll be able to show you that students can actually do and download in their classroom in just a moment. Now, take a look at how beautiful these satellites are. These satellites will actually move around, and they're searching for magnetic reconnection regions that are around the Earth, because we can reach the Earth's magnetosphere, and we treat it like a laboratory. Now, as they go around and find a magnetic reconnection event, they will fly around in formation, and they have over 26 instruments aboard each one that will all snap at the same time. There are no cameras, but we get 3-dimensional data. That's why we have to have 4 satellites.
Yeah, that's really quite a formation with those giant antennas, and I'm glad you brought your visualization with us.
This is one of them.
On that magnetic field reconnection events around the Earth, I understand that it can really impact power lines.
It sure can. It sure can. And somewhat in 1989, for instance, there was a large power outage in Canada and northeastern United States that lasted several days, and it was pretty. Basically, we're also experimenting with virtual reality, so we will have files online very soon for you to go and look at the satellite in space with. You can use Google Glass, you can use Oculus. There's several different ways to be able to do this, and it's just amazing. It gives you a sense of presence of actually being in space, or even on Mars or other planets if you choose.
That's really fantastic. I'm looking forward to that. We still have clouds overhead, but I'm looking to where the clouds are coming from, and there's a big blue patch coming on here.
I'm
And
excited.
that gives me a great hope for clear skies and totality. In fact, here's the sun coming through a quick hole right now.
Oh, that's beautiful.
We can go to telescopes here, and that wonderful arch of the sun and that prominence.
Oh, look at isn't that beautiful?
Yeah.
It's like the sun decided to show off for us a little bit today, didn't it?
It's great to be able to have it pop through those holes in the clouds so we can see it. There's a cloud eclipse again.
You know what, Paul? When I look on the horizon, we have clear skies coming in just about 30 minutes or 30 seconds.
I think we got some really good clear skies coming.
We have some great viewing opportunity.
Yeah. Well, let's go back to telescopes for a minute. There's a quick gap there. Oh, thank you, Troy Klein.
You are so welcome
coming
with
in
all my toys and gadgets.
Yeah, thanks so much for sharing all that with us.
And hi to all of our students around the world with the MMS mission. It's exciting.
Yep. I
Thank
think
you.
now we just want to get ready for totality.
I think
It's
we
getting
do.
close. People are excited. Do you see how dark it is?
Yeah, it's really dark.
It's really dark and it's so cool. We've been sweating for days in the heat here, but it's noticeably cooler. There's a nice breeze. I think the drop in temperature is having something to do with the dissipation of the clouds over our head. I think you mentioned it, but just in case you didn't, we're seeing a big, huge blue patch behind the sun. I'm not worried about totality. I'm sure we're gonna be able to have a great experience of it. Why don't we just keep looking at the telescopes though for a little while?
Now that it's clear. Yeah.
Now that it's clear, let's let everybody get a good view of this small crescent with that huge, huge prominence. It's absolutely gorgeous. I would say here on Woolly Eye, as it dims, we've got probably, I don't know, 250 people standing around us. It's mostly the Woollyans. A lot of the people from the high school are here. We're seeing a lot of students. We have the crew of the Solitude 1 here. We're getting a lot of cheers from the scratch
Yeah, that's
size.
great. The kids are watching a video monitor, seeing what you're seeing out there in the world, and we just hear these yells and cheering going on whenever something really cool shows up.
Yeah, and also every time the clouds show up, there's sort of a boo,
Quiet.
and then as soon as the sun reappears, we get a big cheer. So what I'm seeing now over our head is just a few wispy clouds remaining in the sky. I think we're going to be good. There's a small patch, maybe 10 minutes, but it's very wispy.
Yeah.
And I think the temperature change again might dissipate that, so we're looking really good. We're now about 10 minutes, is that right, from totality?
Yeah, it's about 10 minutes from totality.
Okay.
So it's looking good.
So why don't we talk a little bit, since we have some time right now, about what it is that's going to happen in totality. We keep mentioning it, but we haven't actually talked about it directly.
Yeah, so as this crescent gets smaller and smaller, thinner and thinner, it'll get shorter and shorter until just one little bit of the photosphere is left uncovered by the moon. And that will lead to a phenomena called the diamond ring, with a bright spot like the diamond and a gentle ring of light around the moon.
That's right, and so we have an image of that. Now this isn't right now.
No.
This image was taken a couple years ago, but it does show the diamond ring. It's going to happen quickly. It's only going to last for, what do you think, 15 seconds?
Oh, much shorter, just a few seconds.
And so we'll have that moment of the diamond ring, and we'll probably get excited. We'll probably be yelling, diamond ring, diamond ring, diamond ring. And then the next thing we'll see is called Bailey's beads.
Bailey's beads. And so the moon is not a smooth sphere. It has canyons and mountains on the edge of the moon. And the photosphere light can leak through those canyons and give us things called Bailey's beads. And so we'll also call out Bailey's beads if they occur.
If they occur.
It's different. The edge of the moon is different at every eclipse, so it'll be a unique expression. And when the Bailey's beads comes out, and you're looking through your glasses, when the Bailey's beads disappear, you see nothing through your safe viewing glasses. That's when you take off your glasses and look at totality.
That's right. I think that's something, again, people don't realize is actually when the disk of the sun is completely covered by the moon, you can actually look at the sun with your naked eyeballs. But I want to backtrack just a minute about Bailey's beads. And if we see them, we'll yell it out. But I just want to, what you're telling me is that there's little valleys and little divots on the edge of the moon, and that the light will leak through them, and we can see that?
That's right. The light just shines through that gash on the edge of the moon, and you see the photosphere, and it makes these beautiful Bailey's beads. And then, when we get to totality, this is just an image. This is not live right now.
Again, this was recorded a couple years ago.
We'll get to see the corona of the sun, this white light reaching out from a black disk, which is the moon blocking the photosphere of the sun. And the corona was discovered during a total solar eclipse, the first drawings of the corona. And in the corona, as you see it, there will be lines, perhaps, the lines of the solar magnetic field, reminding us the sun is a magnetic body.
That's right, and it's not even going to look like this. Hopefully it'll look really different.
Right. That's right. Well, we'll see. That's one of the great joys of every solar eclipse looks different.
Yep. And
that's why we have to go to them.
And I just want to point out, you're really fading from my view.
It's really beginning to get dark, and the shadows are quite strange on the ground.
Right, I'm actually not seeing many shadows. They've kind of disappeared. Things feel a little weird. It's like twilight, but not really.
Yeah, definitely twilight. And sometimes the evening animals, the birds, start to sing in the forest during this darkening time. So we'll listen in to hear what we hear. Mostly I hear people being very excited by the sun being such a thin arc of light.
Yeah, it's true. We did ask the high school students when we were out at the schools if there was a lot of night song from the local birds, and they said that there was. So it's something we should listen for. I'm not sure we can hear it here on the runway, but we do expect animals to go into their nighttime behaviors. They definitely interpret this as twilight.
They do.
So we're experiencing that last little wisp of clouds. I'm not sure they're going to show up on the telescopes at all, but after these few little wispies, there's absolutely clear skies. So we're going to experience a fantastic totality. Again, we're seeing that crescent get thinner and thinner. We still have, believe it or not, a full 5 minutes to go. So there's still some time. Oh, look at that image. It's just absolutely beautiful.
Oh, that's a nice one. I really like the sun. And now, if people are looking, they can see it directly with the safe viewing glasses. You can use safe projection techniques to project that crescent on the ground. If you're under trees and you look at the ground, oh, listen to the yell.
We're getting a lot of this. I think that the local people are anticipating that we're closer to totality than we are. It is. It's so noticeably dark. The temperature has gotten so much cooler. We're getting a strong breeze. And so I think that this is all in anticipation of totality. This is definitely an exciting thing.
Yes, I'm getting chills. It's not just because it's getting cold.
It is. And the local community here is certainly giving it 3 cheers. Excitement is mounting. We are getting very, very close. People are shouting it's dark in the crowd. There's a lot of yelling and merriment, a lot of excitement. With my safe viewing glasses, when I look up, I am just seeing the smallest, tiniest of orange crescents. So we're going to sit for a few more minutes, continue to watch.
If they're this excited by
I know, I can't
the
wait
arc of the sun, wait till they see totality.
I'm having a hard time being patient. I want to speed up the sun. The shadow is moving across this pole at 1,000 miles an hour.
That's
We're
right.
getting very near the darkest part of the shadow. I see that the crescent is starting to shorten. We're getting very close. Very, very close. I'm sure people at home can hear the crowds and excitement here. We're anticipating a diamond ring.
Oh, a tiny little sliver. Oh, it's really getting dark.
Here we go.
Here comes the
Very
shadow.
close.
Diamond ring! There it is.
Diamond
it's
ring effect.
great.
Oh my goodness. That is the most beautiful thing I've ever seen. Now we see the streamers.
Oh!
They're reaching out into the sky.
The corona is so nice. Look at the lines.
Notice we're getting a really strong streamer on the lower left-hand side.
Oh, wow.
It's absolutely gorgeous. I'm seeing stars. I believe I see Regulus.
Oh, yeah. So that's Venus and Mercury.
Venus and Mercury. We're not seeing other stars right now, but we are seeing Venus and Mercury.
Yeah, the sky has gone dark. It's like night coming on, and the clouds around the horizon are dimly lit with yellowish brown. It's the sunlight's still hitting the distant clouds. Oh, it's dark here.
I see birds flying overhead. Actually, a lot of birds have come out of the trees and they're circling.
Oh, and that prominence sticking up into the corona.
That's unbelievable.
It's just gorgeous. What a great set of cameras.
Absolutely gorgeous. If I put on my eclipse glasses, I cannot see a thing. We're all looking with our naked eyes.
That's a prominence.
So people in the crowd are asking us what the red prominence is.
They have good eyes.
They have very good eyes. Again, it's cool. It's the coolest it's been since we've been here.
Oh, this is just
Everyone
amazing.
has stood up and gathered around. The hundreds of people were sitting, relaxing in the shade. They're all now standing up in giant clumps. There's a lot of kids running around.
It was really great to prepare the kids yesterday to tell
irse a sus nidos y después apenas aparece el sol de nuevo, se dan vuelta, una vuelta en U y se regresan. Es una cosa muy chistosa. Pero todavía vemos acá qué hermosa vista de la corona solar, que es en el único momento que podemos ver la atmósfera más externa del sol.
Se vale tomar
no
fotos, pueden
Ay,
inmortalizar
sí,
este
fotos,
momento.
Saquemos un selfie
porque no
en
estamos
este
en Micronesia,
momento.
pero no se puede lograr algo más.
Ay, no, qué increíble que está,
Mira
¿no?
qué cosa más emocionante, Isabel.
Realmente. Y lo que, viste que uno dice, ¿cómo puede ser que ver esto en video se vea tan emocionante, ¿no? Porque parece que uno está ahí. Es que realmente se están trayendo estas imágenes en vivo y es un regalo, es un gran regalo. Y yo les doy gracias a nuestro equipo del Exploratorium y a todos los que han puesto este evento, que tenemos un patrocinio de la NASA y patrocinio de la Fundación Nacional de Ciencias. Damos gracias a Univisión por prestarnos tu presencia para poder compartir este momento tan hermoso.
Para mí es un honor y yo quisiera preguntarte
Mira,
porque
ahí se ven estrellas.
creo que a la izquierda,
Mira, hasta
a la izquierda
ahí
se ven un par de
estrellas.
estrellitas y abajo
Mira,
también.
aquí abajo también, o sea, están mostrando lo que es el cielo nocturno en este momento.
Isabel, yo sé que se lo están preguntando entre la audiencia, ¿quiénes son los suertudos que llegaron a Micronesia? ¿Cómo los eligieron?
Yo pienso que realmente yo he visto, por ejemplo, pues yo tuve la suerte de ir una vez, ¿no? Porque hace varios años que venimos haciendo este tipo de programas, desde 1999 hasta ahora hemos hecho, no sé, como media docena de este programa, y los productores siempre tratan de ser justos y dar oportunidad a varias...
Se está empezando a abrir, Isabel.
¡El otro anillo de diamantes! ¡Por favor, no te lo pierdas!
¿Eso es lo que llaman el anillo de diamantes?
¡Ay, no! Se fueron
Lo capté antes que se fuera. Es una nube, seguramente
me vas a
aparece
pasar
ahora.
esa foto.
Seguramente aparece
¡Ay,
ahora.
sí!
Míralo ahí.
¡Fantástico! Sí, me la pasas.
Te la paso.
Ay,
Busquen todo
no.
esto, lo vamos a tener en nuestras redes sociales para que las puedan ver las fotos también.
Mira, ahí han puesto, creo que... ¡Ay, sí! Está
Ahí está la
apareciendo
creciente
de
apareciendo
nuevo.
ya a la derecha, Isabel.
Claro, aquí vemos nuevamente
Y
la
entonces,
luna
desde este
salir.
puntito hasta que la luna despeje completamente, ¿cuánto tiempo?
Y ahora, bueno, todo el eclipse dura 2 horas y media, entonces la mitad, ¿no es cierto?
O sea que ahorita hora y pico.
Una hora y cuarto.
Ok.
Sí, hasta que desaparece totalmente la luna del frente del sol
Wow.
para poder recuperar la fotosfera solar completamente.
Qué
Y ahora
maravilla,
mira,
qué
lo que
momento.
quisiera es que agarremos la oportunidad de tomar preguntas
Justamente
de nuestros
de nuestro
televidentes,
público.
por
¿Tienen
favor,
alguna
nuestro
pregunta?
público,
¿Alguien? ¿Tenemos
alguna
niños,
reacción,
tenemos
por favor?
jóvenes, tenemos no tan jóvenes?
¿Qué les pareció?
¿Cuánto tiempo delata para la luz del sol para pegar su ojo?
¿Cuánto
tiempo tarda la luz del sol para pegarse
pegar
al
su
ojo?
ojo? Mira, el sol está a 150 millones de kilómetros de aquí y a la velocidad de la luz, que viaja a 300.000 kilómetros por segundo, lleva 8 minutos para el fotón que sale de la fotosfera solar llegar a nuestro ojo.
8 minutos.
8 minutos. Sí, exactamente.
Rápido.
Wow, ahí se ve de nuevo. Otra
Ahí
prominencia
hay
más.
otra
Qué
prominencia a la
bonita,
derecha.
está
Esa no la vimos
claro. Ahí vemos otro
¿Alguien
tipo
más
de...
tiene una pregunta?
Hola.
José? Hola.
Sí, por acá.
una pregunta
Primero,
más.
muchas gracias, muy bonito la explicación, le ayuda mucho a uno a entender esta maravilla de nuestro sistema. Queríamos preguntarte, el del año entrante que va a suceder en agosto, ¿se puede ver en Latinoamérica?
No, solamente en Estados Unidos, en Norteamérica, desde Oregón hasta el sur de Carolina. Y antes de eso va a estar sobre el Océano Pacífico en el noroeste y sobre el Atlántico en el sureste.